Hi guys, continuing with our discussion, we actually have been talking about VXLAN in my previous video. We actually brought up the underlay in this particular leaf spine topology, right? We also did the BGP configuration for activating the L2 VPN address family, right? So in this video, our main goal is to basically build up the connectivity between these two hosts, right? So our whole goal is to create the L2 overlay over the L3 network, right? So we'll be mainly talking about two route types, which is route type 2 and route type 3. Okay, so with that, let's get into the configuration here. So to start with, all right, so let me pull up my leaf switch, right? So we have the leaf switch 1 over here. Let's go in there. First, let's check if we have the VLANs, right? So we have the VLAN 10 and 11 on this guy, and on the other leaf switch we've got the VLAN 10 and 12, right? This is again going back to what we discussed in the previous video. If you have not checked that out, do check it out, right? So let's start with configuring EVPN, right? So for EVPN you have a dedicated config section. So we go into VPN, we enable it for VLAN 10, right? So remember in our earlier dedicated VXLAN playlist, we have talked about things like MAC VRF, right, and IP VRF, and the L3 routing table. So those are the concepts which are getting used here. So you can see EVPN, we are getting into VLAN 10, and we are now basically in the MAC VRF configuration, right? So when you talk about VRF, you need two things. You need route distinguisher and you need route target, correct? Route distinguisher will help you to kind of uniquely identify a MAC address, right, within a particular VLAN, right? Whereas route target is basically used for defining what MAC addresses you want to export and import, right? So let's do that. So RD, now you can actually explicitly define certain route distinguisher if you want, or I'm just going to let the system figure it out. So I'm going to say RD auto. Same thing with route target export, it's going to be auto, and route target import is also going to be auto. Cool. Next, let's move on to the other VLAN, which is VLAN 11, correct? So in VLAN 11 we are going to have exactly same thing, right? So we're going to do RD auto. Let's do route target export auto. Let's do route target import auto. So we are done with that. Let's quickly have a look, right? So the VPN config is VLAN 10, VLAN 11, you have the RDs, you have the RTs. Okay, what's the next configuration which is needed? So the next configuration is basically we need to enable the let's actually go and do this configuration on the other leaf as well, right? By the way, let's also check is our show IP interface brief, and I think 192.1.6. Okay, so let me just see what is the configuration on. So we have two leaf show interface brief, right? So there you go. So 1/1 and 1/2 are basically our server facing ports, which is these two guys. So they are already enabled. Okay, that's fine. By the way, I've been doing a wire capture here so that I can show you some of the things once configuration is done, right? But that's okay. We'll also do a complete traffic flow maybe at a later stage, maybe in the next video. But in this video, the main goal is to make sure that the connectivity work. Okay, so let's go and show run EVPN. So that's the configuration. Let's gonna keep everything same except the VLAN number is going to change, right, on this guy. So that's gonna be VLAN 10, but for VLAN 11, instead of VLAN 11, I'm gonna go with VLAN 12 because those are the two VLANs on leaf 2. Let's grab this guy, paste it, and we are done. Alright, so the last part is to get this to work, what do we need is we basically need the VXLAN configurations, right? So we need the VXLAN configurations. So let's go and do that, because currently the VXLAN configuration, so we have just enabled EVPN, the MAC VRF, but we haven't defined what is going to be the VTEP, right? The VTEP IP, and we have also not mapped the L2 VNIs, right, to the VLAN. So that's what we are going to be doing next. So coming back to the leaf 1, right? Let's get into interface. Maybe let me do one thing. So let me shut the ports 1/1. I'm going to shut the access ports 1/1 and 2, right? So let's do the same thing on the other guy as well. Right, so I've shut the server facing ports for now, so that we keep everything clean. We'll unshut it in a while, but for now let's first go and enable interface VXLAN1, right? So that's going to be the VXLAN tunnel. What is going to be the source IP? I'm going to use 192.168, the other loopback, right? So you see from the topology, we're going to use the 11.3 over here, right? So we're going to use 192.168, 11.3, let's say no shard. Then we have to map the VNI. So I'm going to use a VNI of 10010, and that is going to be mapped to VLAN 10. We will then use 10011, and that gets mapped to VLAN 11. Perfect. So I think that's good. Let's get on to the other guy, right? So here as well, let's do the same configurations, right? So it's going to be interface VXLAN1, source IP here is going to be 192.168.11.5, right? Let's do no shard. VNI is 10010, VLAN 10, right? Let's also do VNI 100, but this time let's do 12, right? So let's use a different VNI here because it's a different L2 domain, right, for VLAN 12. Alright, so I think we are done with respect to all the configs. If you want to quickly have a look at all the configurations which we have done till now, we could just do a show run, right? Yeah, there you go. So we've got all the necessary stuff here, right? So I think it's from here. Let me grab it to the right. Yeah, so we have started with the, so you've got the VLANs. So we have the EVPN section, you have the physical interfaces. By the way, we have shut the access ports, right? We also have the configs towards the spine. We will then have the loopbacks, and then we have the VXLAN configs, and finally the OSPF and the routing configs. So that's the all configurations which you need for the connectivity to work. Okay, let's do some quick testing here with respect to show commands. Let's see, look at what do we see. Let's look at show EVPN EVI, right? So this one will give us all the details. So you can see the two L2 VNIs are shown here. Route distinguisher is here. This is like the route distinguisher which the system figured out by itself, right? There is obviously a formula on how it does. Like for example, here looks like it uses the router ID and maybe the VLAN number. Route target is also automatically generated, these two numbers, right? This is the route target which it is exporting and importing for this particular MAC VRF. Okay, so on leaf 1 we have two MAC VRFs, right? For one is relating to 10010, other one is 10011. Same thing on the other guy. If you go down here on the second leaf, you will basically find 10010 and the other one is 10012. Cool. Let's again go and verify that our BGP and all is working. Show BGP L2 VPN EVPN summary, right? So there you go. So we have on leaf 1 we have connectivity to the two leaves. We can see that it's in established state, which is great, right? Now what do we do next? Let's start by, so remember we have shut the server ports. By the way, I've already configured the IPs on these servers, right? So I'm going to just get into just the leaf 1. So I'm going to go into one of the interface. I'm going to do a no shut, right? So the moment I do a no shut, there will be some gratuitous ARP, right? Which basically this client would continuously be sending. So we should ideally be seeing that this particular MAC address of this host. Let's figure that out. Let's come to the host over here. Let me just do that. Disconnect. So if you look at the MAC address of this guy, right, show IP interface brief and then show interface Ethernet 0/0, right? The MAC address is ending with 5000, right? So if I go on to my switch or leaf 1, and if I just look at MAC address, right, still, I mean, till this point there is nothing completely unique, right? This is nothing but how the switch operates. The switch has learned the MAC address because that's what it does using source learning, right? And why did it do that? Because the server obviously sent some gratuitous ARP, right? Some sort of traffic was sent out, like a GARP, right? So that the leaf 1 basically was able to learn the MAC address on this particular port. Cool. Now let's move ahead and look at what's happening with respect to this MAC address. Did this get learned into EVPN? So for that you have to do show EVPN MAC IP. There you go. So you can see this got learned with this particular L2VNI. This is the MAC address, and you can see the flag is L, right? It basically means that L means local. So this particular MAC address was learned locally. Okay. Now next, as we all know, for for L2 for the L2 overlay to work, we need route type 2, right? I will actually show you packet captures in a while, but before that, let's go into BGP, L2 VPN, EVPN, and what is the VNI? VNI is this guy. So let's grab that and route type 2. Cool. So when you look at that, you can see that this is the MAC address. So you can see a type 2 route. That's the MAC address, and the next stop is 11.3, right? Always observe this. The next stop is not the loopback 0. It is loopback 1. Why? Because that is the IP which was used over here, right? This is the IP. So this gets used as the next stop. So you can see that's the next stop. Perfect. And typically, I mean, this is a BGP route, so it is going to have other BGP attributes, right? In addition to that, you can see the route distinguisher is also present over here. If you want to see more details, what you can also do is, let me clear the screen. Sorry. Yeah, in addition to that, if you want to do, you can also do show L2 VPN, BGP, L2 VPN, EVPN, and then take this router distinguisher, paste it here, dash, and copy the whole route, right? There you go. So now it gives you information, more information about that specific route. You can see the route target is visible here, right? In addition to that, it also shows the other BGP attributes and if it is the best route and all of that, right? So this is, again, what we have done till now is we have looked at the MAC address got learned locally on the switch, and it was then sent to the EVPN instance local to the switch. Okay. Now this particular update will go as an update, BGP update to the other side, correct? So we will have to go and look for that particular packet capture. So give me a minute, let me find that packet capture and show it to you guys. All right, so I was able to pull the BGP update message, right, which is of interest for us. So you can see this particular BGP message, right? So this is the BGP update message going from leaf 1 to spine 1. And if I strip this down, right, you can see this basically says it's an update message over here. Okay, then let's come to the path attributes, right? So you can see the extended community. Let me just pull this a bit top if I can. Yeah, so the extended communities is what we can see, and inside that you can see there are two carried communities. One is the route targets and the other one is the encapsulation type. So we are telling, hey, to reach to this particular host or this particular address, you have to use VXLAN, right? This is going from leaf 1 to leaf 2, remember, or from VTEP 1 to VTEP 2. Next, as I come down, so this is the reachability information, and we are clearly calling out what is the address family, L2 VPN, EVPN, right? There is also next hop given here, which is 192.168.11.3, which is leaf 1, loopback 1. Then we are also telling what type of a route advertisement this is. This is just a MAC advertisement route, right? Because MAC, the route type 2 can have two types of routes. One is your MAC, and then the other one is going to be MAC plus IP. So MAC plus IP, you get it only when you get to symmetric IRP, or when you get to the routing piece. Right now we are just doing bridging. So the leaf 1 doesn't even know the IP address, right, of the host 1, right? So it has just done source MAC learning, so it just knows the MAC address, so it is sending that out. So you can see this MAC address is over here, right? And this is going to be the route distinguisher, and this is the VNI, and you can clearly see IP address is not included. Okay, so that's how the packet looks, or the update packet looks, right? We can see some of this on the device as well. So now that we have sent this update all the way to leaf 2, if you go on to leaf 2, and if I do show BGP L2 VPN, EVPN, and route type 2, right? If there is no issues, then basically host 101, the MAC address of that should show up on the leaf 2. There you go. So you can see it obviously is getting 2 updates because we have 2 route reflectors, right? And I don't think I have configured both of them to be in the same cluster. That's why you're getting 2 copies of the route from route reflector 1 or spine 1 and spine 2, and based on BGP algorithm it is picking one of the best one. But you can clearly see here the best route is this one, right? And on top of that, it is also finding the next hop to be the VTEP, right, of leaf 1. Okay. The next is we can now look at from the EVPN, from the BGP, is it coming to the EVPN, right? So we can do show EVPN MAC IP, and you can see the MAC address is coming down here, and here it is clearly called out as R. R basically stands for remote, so it is remotely learned. Okay. Last part is show MAC address table, right? From your EVPN table, it has come into the MAC table, and here you can see MAC address. It has come into the VLAN 10, and it is clearly telling us that to reach this you have to use the VXLAN as the tunnel. Alright, so that kind of closes on how the route type 2 is sent from leaf 1 to leaf 2. Now let's talk about the other important route, which is the route type 3. Alright, so before getting into route type 3, let me also unshut the other host, which is over here. Disconnect. So this is the other host in the VLAN 10 space, right? So I'm going to just go and unshut it, interface 0/0, no shut, and then what is the MAC address of this? It's gonna be so it's gonna be 7,000, right? The other host was 5,000, and I'm sorry, this guy was 5,000, right? That's what we saw earlier. Scroll top, right? Whereas this guy, the one on the other switch, ends with 7,000. All right. So coming back to the leaf, right? If I do show L2 VPN, show BGP L2 VPN EVPN. Basically the same thing should have happened on leaf 1 as well. That is, the host on the leaf 2 should have been learnt here, right? Route type 2. There you go. So we still have 5,000. The reason is because I think we have not unshut the interface on this guy, right? So let's unshut the interface on leaf switch. So this is going to be no shut. So the moment you do that, we are basically unshutting the access port, right, towards the host. So here you can see not yet. There you go. Now it's here, right? So you can see L2 VNI is same because we are talking about the same L2 VNI. We're just doing L2 overlay, but this is the route distinguisher for leaf 1. This is the route distinguisher for leaf 2, right? And you can see from leaf 2 we are basically learning this particular route, which is the new host which we unshut just now, right? And the next hop you can see is leaf 2 11.5. Okay. Similarly, you can also have a look at show EVPN MAC IP EVI and 10010, right? So now you can see on the leaf 1 the 7,000 MAC address shows as next hop is leaf 2, and here it says the total MAC addresses are 2. One is the remote one, which means the other one is the local one. We can also look at the MAC address table into the VLAN 10, right? You can see the EVPN learnt MAC is over here, right? And this is the one which has been learnt via source learning. All right, so that's important. Now the important question is, what happens when an ARP request, so basically bump traffic, right? So when bump traffic is generated by one of the hosts, basically this host, right? So when bump traffic is generated, or broadcast unknown unicast and multicast traffic is generated, right? How does leaf 1 know that it has to send that bump traffic to leaf 2, right? You have to, right? Otherwise, the ARP will not work, and this host will not be able to talk to this guy, right? Let's go back to basics. In order to ping between the two hosts, you have the IP address, but if you don't have MAC address, you have to do an ARP request, right? But if the ARP request is not sent out by the leaf, right? Because this is all L3 network, correct, over here. So if the leaf 1 is not sending out the bump to the right VTEP or the leaf 2, then the ARP will not reach this guy and communication will not work, right? So to do that, there is actually a hidden, there is actually another route type which is kind of working in the background, right? Now in case of, if you remember from the previous couple of videos before, we did static VXLAN, and when we did static VXLAN, we explicitly configured what is going to be your VTEP peer, right? Which means all the bump traffic for that VLAN or for that VNI was sent, and statically it was defined what your leaf 2 is. But in case of BGP VPN, that happens automatically, and that feature is basically called as auto discovery using route type 3. What I mean by that is, if I come to, probably, let me clear the screen. So if I do show BGP, L2 VPN, EVPN, VNI, right, and if I do 10010, right, so that's the VNI for VLAN 10. You can basically see all the various route types here, right? And one important route type which you will spot here is this guy, correct? So you have route type 3, and then there is another route type 3 over here, right? And what it actually means is basically that for which L2VNI, for 10010, VTEP 1, right, which is leaf 1, is basically telling the rest of the world, hey, you know what, I have the L2VNI 10010 configured. So if there is a bump traffic, right, which needs to be sent for this VNI, send it to me, right? That's the meaning of this. Similarly, the second leaf is also telling the same thing. It is telling that, hey, look, I too have the L2VNI 10010. So if you want to really send the bump traffic for this VNI, send it to me. So that's the meaning of the route type 3, right? We can further drill down, and we can probably look at the way we did earlier. Show BGP, L2 VPN, EVPN, and let's use let's use this guy this time, right? So let's use 5 dot this thing, let's put a dash, and let's use this particular route, right, to get more information. And here you can see, so there are going to be 2 routes, I believe, because it's coming from, it's next, there are going to be 2 routes. One is going to be the best here, and the other one is not going to be the best, because like I said, it's based on there are 2 route reflectors, right? But anyway, the important information here is, you can see for this particular route type 3, it is getting tagged, it is coming from this guy, this particular VTEP, this is the VNI, and the route target is also present here, so that it gets imported into the right MAC VRF. Cool. Now let me pick up the the packet capture for this route, so that I can explain that as well. Alright, so I was able to find the PCAP, right, pertaining to this. You can see the BGP update has gone from leaf 1 to this has come from spine 1 to leaf 1, right? And this one is carrying the information about actually which VNI is this one? Let's see. So actually it's come from the top, right? So here you can see you understood from where it is coming. Next, let's look at that. This is an update message, right? Then if you come under the community section, you can see that it is going to have the route target, it's going to have the VXLAN encapsulation, right? Which is kind of important, right? After that, the most important piece is the path attribute, right? So here you can see this is what it is going to have, right? So it's having information about the endpoint for the tunnel. You can see this one, this is the VTEP, right, to which the bump traffic needs to be sent. You can see ingress replication being mentioned here, right? The VNI is present as well, and you can see ingress replication mentioned. Okay, similarly, as I come down for the reachability information, you can see address family is correct, L2 VPN, EVPN. You have the route type, which should be route type 3, you can see that, and finally the route distinguisher as well, right? So very similar to how we looked at the route type 2, which is the MAC route, we are able to now see this one as well. Cool. So now coming back here, right, if I probably look at few more show commands, if I just look at show BGP, L2 VPN, EVPN, right, just to enter, you basically get all the routes now, right, for the L2 VNI, which we have been working on. And you can see route type 3 is learned over here for L2 VNI, this guy. And remember, we also have other L2 VNIs, right? So we have 10011 and 1012. For that also you can see it is getting learned. But at the same time, this is a good example, right? On leaf 1 we don't have this particular VNI, correct? So that's why you see out in the list you will not find leaf 1. Similarly, on leaf 2 we don't have this VNI, so that's why you don't see leaf 2 over here. So that's the main point of this, right? We can actually look at some more details. We can look at show EVPN, EVI, 1010 and detail, right? Sorry, 100, I think I missed out a 0 over there, right? So you can see for this particular L2 VNI, we are basically telling that the only VTEP to which I have to send the bump traffic is leaf 2. Similarly, if I do for 1.1, right, you will not see anything because the leaf 2 doesn't have this VNI. If I do 1.2 over here with let me see. Yeah, so looks like because you don't have this particular VNI locally on this one, right, you don't get to see any details pertaining to that, but that's fine. It is understood that you don't have at least this kind of confirms that on leaf 1 we don't have 10012 VNI, right? So that is about the route type 2 and 3, right? Now let's do a ping, right? And let's probably see if we are able to communicate. So what's the IP on this guy? It is going to be let's look at the IP here. It is, yeah, so it's 10.1. This guy, right? So I'm gonna get on to this particular host and just do a ping, right? Not that. And ideally, yeah, there you go, the ping worked, right? Let me pull up the data plane capture and show it to you guys as well. All right, so I just filtered for the ICMP, and you can see because we have ECMP, right, between the leaves and the switch spines, you can see the request is going on one of the link and the reply is coming on the other link, right? So you can clearly see that the request went on this particular link. Below you can see VXLAN, the leaf has encapsulated this in VXLAN, correct? And then we also have the VNI, right, which is the L2 VNI. So the request went on the other side, reply is coming from the other side with the L2 VNI of 10010. Perfect. And you can see, let's also probably look at the request once again. So I think this is the request. So you can see this is the ICMP packet, and you have the inner IP header going from host 1 to host 2. Then you have inner MAC address, right? This was done obviously using ARP. In fact, I think if I search for ARP, I should probably find it here. So you can see there's an ARP request which has gone here, right? Where the host 1 is basically asking host 2 what is the ARP, right? So you can see ARP is also encapsulated in VXLAN and sent because of the route type 3, right? Because leaf 1 was able to identify that the L2 VNI is sitting behind leaf 2, so it encapsulated ARP, send it to the other side. The ARP reply would have come on the other link, right? So that's why it learned, and then the ICMP request is also working, right? So that's the whole workflow of how the control plane works, how the data plane works with respect to how you can create a L2 overlay between these two hosts. Okay, hope that was useful. We'll come back, we'll continue from where we left, and we'll talk about symmetric IRB in the next one. Thanks a lot for watching, guys. Have a good one. Bye.